Hello, everyone. It's me, Mark Baggett. Glad to be back with you again. Did I change my shirt? Well, I don't know. I don't know if my shirt matched or not. I guess it depends upon what I wore when I was on here live presenting with you this morning about SEC 573. This presentation is recorded because, well, I've got 25 minutes and I want to make absolutely sure that I'm able to fit all of the information that I want to talk to you about in this section about SEC 673 and some of the topics we talk about there into the 25 minutes that we've got available. So this is going to be an edited video where I'm putting together this content just to make sure I can get everything in here. So if you don't know who I am, I'd suggest you go back and watch that recording from that 573 video because I'm not going to spend a lot of time talking about that here again. So what I want to talk to you about today is I want to talk to you about the fact that Python apps are a real pain in the rear sometimes, right? They can be difficult to install. Python isn't installed on Windows by default. We have conflicting libraries, but I need all of these different Python apps to run. So let's talk for a little bit about how we can manage our Python apps more effectively and, well, just be better at information security when it comes to these Python apps. But first, let me just make the point that this is important information. Even if you haven't seen it yet, Python dominates the information security application space. The tools that we're using every single day in technology really are developed in Python, and knowing how to manage these effectively and securely is important to our enterprises. Over the last 24 months, as you can see here, Python has grown more than double what any other programming language has grown. Python grew 1% over the last 12 months. The most that any other programming language has grown is 0.03%. That's Rust. Rust was the second fastest growing programming language over the last 12 months. But Python today makes up 28.59% of all open source projects that are being developed. And the next most popular is Java, and that one's at 15.79. Now, if you look at the growth of Java, that one is actually on the decline. And there in the chart you see on the left, I want to point out to you where those tick marks are. So the only one that you see that's nearly at 30% there is Python. Look at the gray lines that we see back here in the windows, right? The 10% mark. Everything else you see is less than 10% mark. This graph is not shown to scale, right? The different percentages are compressed so that it all fits here. But PowerShell, most of the other languages that you see here, Ruby, Rust, are around 1% of all of the programming languages. So really, Python dominates the app space, and we're going to be running these applications in our environment whether we're ready for it or not. So it's important to be ready. One of the reasons we see Python everywhere is because it's the language that's being used to innovate many of the things that we see revolutionizing industries today. Terraform, Ansible, Python is the language of the cloud. TensorFlow, PyTorch, right? Python is the language of artificial intelligence. Jenkins, CI/CD pipelines. Python powers the automation processes, pandas, NumPy. Python is heavily used in data analytics. Django, Fast API, and others. Web frameworks today are often developed in Python. So understanding how Python works is going to make it so that you understand these applications, can find the vulnerabilities in them, and can resolve those vulnerabilities. But today we're not going to talk about developing applications, although certainly if you want to learn how to code in Python, 573 is there for you to teach you how to learn to code. It's the introductory class. 673 is the advanced Python. For those of you who already know how to code in Python and want to grow your skills, that's what 673 is for. Now, I mentioned that Python is a pain. Well, everybody loves Python, right? Well, not everybody. The fact is that Python is great for developers. For developers, they love the fact that Python is operating system and hardware agnostic. I can write my programs, and whether you're running Windows or Mac or Linux, my program is agnostic to that. So you can run that software anywhere. I write it once, you download it, doesn't matter what platforms you're on, whether you're on a Raspberry Pi or a powerful Mac, it doesn't matter, right? Running it in the cloud, I've written it once and it's going to run everywhere. So it's great for developers, but not so much for administrators and InfoSec people, because here's the fact. If you're going to run a Python program, you have to have the Python interpreter installed on your systems in most cases. We'll talk about some options today, though, that can help you get around that. But that's not just the problem, right? It's not just the fact that you have to have Python installed. You have to have all of those third-party libraries installed. So you download this application, you try and just run it, and it says, oh, you're missing this library, and you're missing this library, and you're missing this library, and you install those. And maybe that application works after you've installed those libraries. But unless you've done something to separate the libraries for this application that you just installed versus the ones that you already had, well, it's very possible that none of your other applications are going to work, because you only have one folder where all your libraries go. And so if you have one application that requires version A of a library and another application that requires version B of that same library, you can't have two different versions of the same library by default. So you've got to have some way of managing those third-party libraries and keeping them separate. There's three different techniques we can talk about in order to manage the Python apps that are on your environment. There's Python virtual environments, which is a great way to do this, and it's how I do most of everything that I do, but it's not the most distributable, right? That's what I do on my machine because I understand Python and I want to manage my own libraries. But when it comes time to send those things out to other people, the other administrators that are in my system that I work with that perhaps don't understand Python, or the users in our environments that I want to run Python scripts that are going to actively do things on their computers, I don't want to have to set up virtual environments on their machines, because, well, it's not an easy, quick thing to do. So there's other options out there, like building executables with PyInstaller, Nuicta, and other tools like that, and also PyZip apps. And that's what we're going to talk about today. I mentioned virtual environments as one way that we can manage our applications. This is something that we teach in SEC 573, because if you're going to be developing applications or running Python applications in your environment, understanding what virtual environments are and how they work is an essential skill, right? They have the advantage of keeping all of your Python projects separate. So every Python app can have its own version of its libraries. And this avoids all of the library conflicts issues. The use of virtual environments has been built into Python since Python 3.4. So it's not a problem in using these. And this is a great way to manage the applications on your system if you understand Python and how it works. But it does have some disadvantages. One is Python has to be running on the app on your system. You have to install Python. And if I'm just distributing an app to an end user that's in my environment, then I don't want to have to install Python on their system to get them to run the apps in some cases, right? And the other thing is I have to configure that virtual environment. I have to create it and separate it and activate it before I install those applications. Then I've got to teach the user how to activate that virtual environment so that they can then run the applications or use some of the tricks that we talk about in 573. Now, if you'd like some more information about this, I'm not going to talk about this here, but if you'd like some more information about it, you can go see the presentation that I did called InfoSec Snake Wrangling that talks about how to create Python virtual environments. And you can find that on my YouTube channel. Another way that I can distribute my application is by using a packager like PyInstaller. And these are applications that will take our Python programs and all of its dependencies, and it'll package them up into an exe that an end user can run on their system, right? So the big advantage here is that, well, for the end user, they don't have to have Python installed. The executable that we're going to build has the Python interpreter installed. They don't have to configure things on their system. The executable has all of the modules and our program and everything else into this self-contained. In many cases, it's like a self-extracting zip file where you run the exe, it expands everything into a temporary folder, runs it, and then cleans it up when it's done. Now, the disadvantages of this exe is, well, it's very similar to other compiled languages like C and other things. Once you build this exe, it's a Windows exe that's going to run only on Windows systems or Linux systems with Wine or other things that know how to run an exe. right? I'm going to build it specific to a hardware architecture and an operating system. And that's where that's going to run. But this can be very powerful because it eliminates the need to install Python. And this is something that we teach in SEC 573. Now, the steps in order to build a PyInstaller executable is one, you've got to install Python and PyInstaller on a computer, right? It doesn't have to go on all the computers that you're going to distribute it to, but on one computer where you're going to build the executable, you have to install Python and you have to install PyInstaller. Now, if I'm going to be building a Windows executable, well, then I've got to do this on a Windows computer. If I'm going to be building EXEs or apps to run on Macintoshes, then I've got to do that on a Mac. Same, Linux builds Linux, Mac builds Mac, Windows builds Windows. And then I have to install all of the dependencies for the application that I want to run on that Windows system where I'm going to build the EXE and get my program working on that computer. Then I'm ready to build the executable. What tools like PyInstaller do is they take the Python interpreter, any libraries that your program depends upon, and a byte compiled copy of your code, and it packages it up into a self-extracting exe. So when the user clicks it, it extracts it, runs the program, and then cleans it up. Now, PyInstaller has several options. It's got a --1 file option. If you pass the --1 file option, it builds the exe such as you see here. It's also got a --no console option. And if you build that, then it'll allow it to build your program so that it runs invisibly in the background, which is ideal for things like Windows services and the kind of backdoors that we talk about building in 573. Now, when you build the executable, it creates a couple of folders. It creates a build folder. This is just a temporary working space where it stores the scripts, the modules that your programs need, and everything else that needs to package into the executable. Puts everything there, and then it takes all of that stuff and it builds the exe, puts the exe into the dist directory, dist, short for distribute. And in there, you'll find an exe that you can then copy to any Windows system and double click the exe and it'll run the executable for you. Let me demonstrate this by building two different executables that we build in 573.
What you see here is a program that we develop in SANS SEC 573. It's a simple command and control backdoor that's going to connect to this IP address here after doing a port scan to find out what ports are open. And then it's going to give the attacker command and control. This has to run on machines that don't have Python installed. So let's use PyInstaller to turn it into an EXE. I'm going to run PyInstaller with the --1 file option, and then pass it the path to the program that I want to turn into an EXE. In this case, it's remote agent.py. PyInstaller is going to go out and it's going to begin collecting up the files that go with remote agent.py. It's obviously going to need a Python interpreter, but it also needs all of the modules that remote agent.py depends on. It also needs a copy of the code to my program. So it's going to combine all of those together into a build directory as a temporary working location. And then it's going to build an exe that it's going to put into the dist directory. So let's change into that dist directory and take a look at the product. Here I can see when I do a dir, there's a remote agent.exe. All right, well, let's not waste any time. Let's go ahead and run that program and see exactly what it does. So I type remote agent.exe and it started. It begins trying to connect to open ports on the remote system. All right, well, now we need to get this remote shell. So let's go back over to a Linux system where I've already got that IP address configured. And on this Linux system here, I'm just going to start up a Netcat listener to wait for that incoming connection. We start up Netcat, I can see it's listening. Now, when the port scanner gets back around to port 8000, I get connected. So now I have control of that remote system. And I can begin running Windows commands such as dir or whoami. This executable no longer depends on Python being installed. So this is an example of an offensive tool that we write in SANS 573, but the utility of this is not just limited to offensive tools. Let's go ahead and do this for a defensive tool that we write in 573. Another tool that we write in 573 is a sniffer. We talk about how to build custom protocol parsers and to look for specific tags using custom sniffers. So here I'm going to take my sniffer, sniff.py, sniff-final.py and turn it into an exe that I can run on any system without having Python installed. Same thing, it's going to gather up my files, build the exe, and then put it into my dist folder. Here I can see it's finishing up. Let's change into the dist directory now and see what it's done. If I change the dist and then I do a dir, I can see I'll have two programs now, remote agent and sniff-final. All right, well, let's run our sniff final and see if we can capture packets. I could run it here from the command prompt, but I want to show you that we can run these from the graphical user interface just as well. So I'm going to browse out to my desktop, go to that dist directory. Of course, it's a sniffer, so you have to run it as administrator. I'll right-click, run as administrator, and there it goes. Brings up a little dialog box and begins showing us packets. Oh, I don't think I want to show that packet. I'll blur that one out. All right, so we'll blur out some packets. Tell you what, let me get some traffic going here that we should be able to see. I'm going to run over here and I'm going to run my remote agent once again, which is going to do that port scanning to try and connect back over to the Linux system. So there it started. We should have some port scanners. Let's zoom in here. There I can see it. Port scanners going to port 81, 443, port 8000. It's just trying to find an outbound port that it can use to give the attacker control.
As you can see, building executables with PyInstaller is very powerful. Now I no longer have to have Python installed on all my endpoints. All I have to do is take that executable and then distribute it to any system where I want them to run my Python app, and they can do that without having Python installed. Now, building that executable, as I said, locks it down to a hardware and operating system, right? An exe runs on Windows. Sometimes I have apps that I want to distribute to users who are on Macintoshes and on Windows systems and on Linux systems. And I don't want to build an exe. I want the portability of a normal Python program that I can install on any system and have it run there without locking it down to a hardware architecture. But I don't want to have to deal with telling the user how to create Python virtual environments to keep things separate. I don't want to have to deal with creating virtual environments and then having to activate them so that people know how to run them. And really, if you're going to build programs that have setup.pys and things like that, you're kind of leaving that up to the end user as to how they're going to do that. And I can tell you that most security professionals don't even know how to manage virtual environments properly. So expecting that your end users are going to do that, it's wishful thinking. PyZip apps is another great alternative. Now, I still have to have Python installed on the target system, but once Python is installed, if I'd like to have a virtual environment, if you will, without having to explain to the user how to create virtual environments and to install all the dependencies, then a Python zip app is a great way to do this. A zip app is really just a directory where we install all of the dependencies. And then if we know a little bit about how packages work in Python, which is a concept that we really introduce and dig into in 673, then we can create a zip app. Now, I'm going to do a very simple application here so that we can avoid a lot of the complexities that you have to deal with large applications. In SANS SEC 673, we break down the package structure and talk about some of the issues you'll run into, like circular imports and other things, so that we understand how a package should be structured. That way, when we download an application from the internet, which often isn't necessarily configured to run as a package, we can make the changes and tweaks that are necessary to make those applications compatible with, say, PyZip app and other distribution methods. Let's just take a look at an example of how we can take one application and all of its dependencies and build that into a zip app that'll run on multiple operating systems without having to configure a virtual environment on all of those systems that I want to run the application on.
So what I want to build now is a little tool that's going to automate checking SANS Internet Storm Center's InfoCon level. If you're not familiar with SANS Internet Storm Center, you can go to isc.sans.edu, and every day they post valuable information for security professionals. They have We have diaries that are written by volunteers who are actively monitoring the DShield database. Speaking of the DShield database, you have access to all of that information, which is like a distributed intrusion detection system. They maintain tools that you can download. And very importantly, in the upper right-hand corner here, you see the threat level, which is green. Being green shouldn't surprise you, but let's see what green means. We scroll down here, we can see the different infocon definitions. Now, over the lifetime of the SANS Internet Storm Center, it has never gone to anything worse than yellow. And going to yellow is actually a really rare occurrence. As a matter of fact, if the infocon changes to anything other than green, you should be concerned. Here's the history of all of the times that the infocon has been changed. And you see that it's only been for very significant events. So monitoring this in an automated form would be very useful. So here I've written a small program that's going to check SANS infocon and then print the current status to the screen. Although the program itself is relatively simple and uses only skills that we talk about in 573, you can see here that it uses the requests enrich module, which are third-party modules, which means an environment's going to have to be configured for it. If I try and just run this program right now without installing those modules, you can see that I get a module name, no module named rich error message. It's because it requires requests enrich first be installed. Now, I could set up a virtual environment and install those modules and things like that, but I want to show you that we can make this program executable without even doing that. What I'm going to do is I'm going to make a directory named infocon app. Now, Python has the ability to run directories that contain packages. Now I'm going to install all of the requirements into the infocon app using pip install. Notice the -t command line argument, which says target this specific directory. Now all of the requirements for that particular program are installed in that directory. Let's take a look in the directory and see what's there. So we change into the directory, and here I can see all of those modules that would have normally been installed in the Python environment are now just installed into that directory. Now I need a program to run those things. So I'm going to copy my infocon py, that program that didn't work previously, into that folder and call it __ main.py. Now, this is a Python package, meaning the directory itself can be executed like a Python program. So let's just take a look at here, do an ls and see what we got. When I do an ls, I can see infocon app. It's a directory, but I can execute that directory by typing Python space and the name of the directory. And there you go. It works just fine. So since I now have a package, a directory with an executable Python program in it, I can now use pyzipapp in order to turn it into a program. So here I'll say python -m zipapp, find the zipapp program and run it, and then I'll pass the directory that I want to turn into an app as the last argument. Now when I do an ls, you can see that it created infocon app.pyz. And this pyz, it's a big zip file that contains everything that's needed to run that program. And I can run it by typing python infocon app.pyz, and it runs that directory. Now this zip file is portable, and I can move it to any system that has Python installed and not have to worry about creating virtual environments and other things. So here, let's just use HTTP server to move it to the remote location. I'll look at my web IP address here, and now I'm just going to connect to this IP address from this Windows system that does not have those different modules installed. I download the infocon app and I save it to my desktop. Once that file is downloaded, I'm just going to open up a terminal window and I'm going to run that infocon app. So let's come out here. I'll change the directory containing the pyz and use py, which is the Python launcher. This is how you launch Python programs on Windows. Run my pyz, and you can see that it works beautifully. I didn't have to create any virtual environments. All I had to have was Python on that system. And that's Zip Apps. I hope you'll find them as useful and powerful as I do when it comes to distributing applications that need to run on multiple operating systems without having to install Python virtual environments or lock it down to a specific hardware architecture. Before I leave, let me mention one other thing. On my YouTube channel, I've started a new series called the InfoSec Toolshed, where I explore the history of some of the tools that have changed information security. New episodes are airing all the time with the backstory on different important tools to our industry. If this sounds like something that you're interested in, please visit my YouTube channel at Mark Baggett and check out all of the InfoSec Toolshed episodes. If you have questions for me about any of the things that I presented here today, please feel free to reach out to me using any of the contact information that you see here on the screen.